open a new sketch and plot a new function 2 plus cosine of x. Make sure that the preferences is radians. Construct points A and B. That'll be your interval of integration. Now make a slider that will measure a value of n. I do it by measuring a ratio of 3 points and then truncating that to the lower integer. And then I'll hide the constructions and make it a line segment. So I have my value of n now. N will be the number of subintervals in our Riemann sum. Calculate 1 over n. I dilate b by a ratio of 1 over n. That gives me my subinterval size. If I then measure the x coordinates and subtract them, I get the value of delta x, which I'm calling dx here. Now, next we'll make a slider that determines the value of the point asterisk. That's the place where we evaluate, the place within each interval where the function is evaluated. So I'm going to start out by constructing 2 free points because you need free points for iteration. R is going to be the left part of our interval. V is going to be used for calculating the value. So now I'm going to construct my first rectangle. I translate R to the right. I compute the location of the point asterisk. And then I have to measure the value of the function at the x-coordinate of asterisk, f of x asterisk. And then I take that and I multiply it by dx to get the rectangle area. Now I'm going to plot some points, but first I need the x-coordinates of the left and right endpoint of the subinterval. So xr and f of x star, xr prime and f of x star, and now I have all 4 points defining my first rectangle. There's my first rectangle, left rectangle, right rectangle. That's basically what the rectangle will look like. The next thing we have to do is compute the value of the integral. And we do that by taking the y-coordinate of v and adding the rectangle area to it, constructing a new y-coordinate and plotting a point. So the point has moved up by an amount of the rectangle area, and we'll calculate a running sum that way. Now it's time to do the iteration. We iterate mapping R to its point on the right and V to the point above it. We need a full orbit. We don't want to tabulate the iterated values, and there are the 5 rectangles plus 1 to the left that we're not going to need. Now I translate a point to the left of A and glue R to it, and I glue V right up to B. Now I construct the terminal point of these iterated points. And when I measure its y-coordinate, that will be the sum of all of the rectangles plus the extra rectangle at the beginning. Subtract that off, and now I have the value of my integral I. Now I can start hiding the things that we don't need in our final sketch, including that leftmost rectangle. And that is our Riemann sum. Left sum, right sum, things in between. I can put A and B wherever I want. I can make lots and lots of rectangles. There's 103 rectangles. Notice when I go to the left of A, my integral becomes negative. That's because the value of dx becomes negative.